Right, so grade 12s, I've also gone and printed out this question. Like I said in the previous sections that I explained, this thing has to be scratched all full of things by the time that you're done. Otherwise, you haven't analyzed the question properly. So let's start. Okay, immediately I can see there's going to be vertical motion. So yes, I'm busy with vertical projectile motion. And ball A over here is thrown vertically upwards. So I want to scan through here to see if they're giving me direction. So very often in capital letters, they'll say take downwards as positive or take downwards as negative. If they don't, then obviously we can choose. Okay, so it says it's thrown vertically upwards from height h with the speed, so they're not giving me direction there. At the same instant, a second ball is dropped. That means initial velocity is 0. From the same height, they both undergo free fall. Do you remember free fall? Here's the first definition. Free fall, so that's the motion of an object in a vacuum. It's the motion of an object in the absence of air resistance. So the only force acting on it is weight, is gravitational force. Now, I'm going to actually take this on my page, and we're going to go backwards and forwards between my page and the question, because I'm going to start drawing pictures. Let's zoom out a little bit. That's as far as it's going to go. Right, so the first thing is I want to go and have a look at ball A, and I'm going to write this is the motion for ball A. So I'm doing that not actually because it moved horizontally. It goes up and it falls back down again, so it's already being thrown off the side of the building, but so that I can just analyze for myself the different parts of motion. Okay, so we've got the initial velocity is 15. If I look over here, it says calculate the time taken for ball A to return to its starting point. So do you agree that would be up, it stops, the velocity here is 0, and then it speeds up again, and this is the same point as its starting point. Now you've got a couple of options here, and this is why I've got different colors. So I always say to my students, you can go and break this up. So I'm going to zoom in quickly. So if you want to work with just that part, then this orangey red part, then use 3 things that go together with the orange or the red part. What do I mean with that? So if I quickly just take, that's the orange part, just to give you an idea. For the orange part, the initial velocity, and I'm going to have to start choosing direction here. So what if I take downwards as being positive? Okay, then if this is being thrown upwards, then that's going to be minus 15, correct? What's the final velocity for that orange bit? Well, it comes to a stop, so that's 0. What I always have in all of these free-falling questions, and all of the vertical projectile motion questions, I always have g. Do you remember g is a constant? It's 9.8 meters per second squared. And just go and double check. So if you've chosen downwards as positive, then all of the g's, because g is 9.8 meters per second squared down. So then everywhere I substitute that is going to be a positive. If you chose downwards as negative, then everywhere in the whole question, you're going to have minus 9.8 meters per second squared. So now that I've got 3 things that are true for this part, I can, for instance, go and calculate how far it went up. Or I can calculate how long it took to go up. The reason I'm saying this is, do you agree if it goes up, I'm making up numbers now, but let's say it takes 1 second to go up. Then it's going to take 1 second to come back to that point. If it goes up 1 meter, it'll fall back 1 meter. So what you can do is with a question like this, where it says, calculate the time taken for ball A to return to its starting point. So you actually want the time, so I'm going to use a different color. So you actually want the time for the whole thing, the yellow. So you've got a choice. Either you can take the orange and work out the time and then multiply it by 2. Or if I'm working with the yellow part, then I just need 3 things that are true for the yellow part. So let's go and have a look. I've still got the initial velocity. Remember, down is positive, so up is going to be minus 15 meters per second. So if I look at the yellow motion, Do you remember if I throw something up at 15, by the time it comes back to this point, its velocity is still going to be 15. But is it going to be positive or negative? Because that's on the way down, so it's going to be positive. So I've got the final velocity after the yellow bit. Now, sometimes students struggle with, okay, but what's the third thing here? You actually have 4 things. So yes, we always have G, because down is positive, so we've got positive 9,8 meters per second squared. And also, there's something really important. So I'm saying here, even though it's superfluous, I don't need to give you so many different variables. But do you agree if I've gone 2 meters that way and I've come back 2 meters? What's my overall displacement? 0. So what's the displacement if you've gone up and you come back down to that point? 0 meters. So do you see you've got more than enough for the yellow section to go and calculate the overall time, if that makes sense. Okay, so what I'm going to do is we're quickly going to look at all of the different formulae that we've got for vertical projectile motion, and then we're going to see which one we're going to use. So it's going to be up to you whether you want to use the orange bit, work out time and times it by 2, or if you want to go with the yellow bit, which will give you the time for the whole motion. Right, I'm just going to do a little trick. Sorry. I just want to look at the next question. Calculate the distance between ball A and B when A is at its maximum height. Do you agree that's there? So I'm actually going to go orange. I can see I'm going to need orange stuff later on. So I'm going to work with this orange part because that's at the maximum height. So just to make my life easier. Okay, let's have a look at the different formulae. We've got final velocity is equal to initial velocity plus g delta t. We've got final velocity squared is equal to initial velocity squared plus 2g delta x. We've got change in displacement is equal to initial velocity delta t plus a half g delta t squared. And we've got change in displacement is equal to initial velocity plus final velocity over 2 times delta t. So that comes just like that from your formula sheet. Okay. Now, quick little trick, how to choose which formulae to use. So go back here. So I'm busy doing question 1.2. I want the time taken for it to reach its starting point. So in other words, if I work out the orange time, then I've got that. Then I can just multiply it by 2. Then I've got the time until it reaches its starting point. So let's work out delta t for the orange bit. So if I look at that, do you see the one thing I don't have is displacement? I haven't worked it out yet. So if you don't have it and you don't need it, then don't use an equation with it in it. Does that make sense? That's how you eliminate the other equations. So I'm going to stick with that one there. So I'm going to go. Final velocity is equal to initial velocity plus g delta t. Final velocity at the top of the orange bit is 0. Initial velocity minus 15, very important. G is 9,8. There's delta t. When I take the 15 over, it becomes positive. A lot of you will actually keep it negative, then you get a negative time and you just scratch out the minus. Guys, we can't get a negative time. Time's a scalar. So do you agree we're going to go 15 divided by 9.8? And I'm going to end up with a time of 1,53. I'm going to just keep that 0 seconds because it's not my final answer, is it? Okay, so just be careful. Which delta t did we work out for the orange bit? So what will I have to do with this? I'll have to times that by 2. And I get 3,06 seconds. So I always like to, on my picture, go and put in things here that I can use it later if they ask me to draw a graph. So I know it takes 1,53 seconds to go up. It'll take another 1,53 seconds to come down to that point, which overall gives me the 3,06 seconds. We put in the initial velocity was 15. I just want to put a little minus in front of it because we took down as positive. So this will be a velocity of plus 15. See, now I've already got quite a bit of information here. Okay, but now I've already answered the question for question 4. Do you see why? Sorry, not question 4, question 1.2, but for 4 marks. Why was it for 4 marks? Because you would have either had to go and do this and click one of those things, or get the answer but times it by 2. That's where the 4 marks comes from. Okay, the next question, 1.3. It says calculate the distance that ball A and B, between the two of them. So in other words, if I quickly try and do this, so A is being thrown up, but as soon as it's being thrown up, B is being dropped. So they're doing this. So they want to know by the time that A is at its maximum height, where along the line is B. Okay, so now I'm going to need a little bit of information for B. Okay, but remember, B, this was all for A. There we go. But remember, B, on the other hand, gets dropped. So its initial velocity, so I'm going to use a different color. So if B's initial velocity is 0, yep, it means it was dropped. Can't change direction here, guys. G is going to be 9,8 meters per second squared down. We've chosen down as positive, so it's going to be plus 9,8 meters per second squared. Okay, so we've got that. Then some of you are going to say, but now I'm lost, because I don't know how far it fell, and did it actually cover H by the time that one went to the top? Listen to what I just said. By the time that one went to the top. So we know that A takes 1,53 seconds to reach the top. Isn't that how long B has to drop? It's got 1,53 seconds. Because they say calculate the distance between A and B. When? They must tell us when or where. When A is at its maximum height. So by the time that A gets up here, how long has it been moving? 1,53 seconds. So because they both start moving at the same time, this one's also got 1,53 seconds before, well, it reaches whichever point. And they want to know the distance between the two. Okay, so I've got, this one's also moving for 1,53 seconds. But I'd like to know how far did it go. So this is all for B. And then obviously we'll have to work out, well, how far A went during that orange part, because I must add the two of them together. Not subtract, I want to get the distance. So if someone walks that way, and your friend walks that way, and I say, well, after 1,53 seconds, what's the distance between you? You're going to add them. Okay, so if I go and have a look at this, excuse me. So if I look at that, you'll see there's something I don't have. I don't have final velocity. If I don't have it, then I don't want it. So I'm not going to use that, not going to use that, not going to use that. Do you see it tells you which equation to use? So we're going to use this one. So remember, this is for ball B, the green one. So I'm going to go change in displacement is equal to initial velocity delta t plus a half g delta t squared. I want to know how far it's gone. Its initial velocity is 0. So that entire first term becomes 0 plus a half. G is 9,8. Remember, it's only the time that's being squared. 1,53 seconds, and that's what I'm squaring. So let's quickly go. Let's see how far it went. 1.53. Oops, I almost times it by 2. 1.53 squared times 9.8 times 0.5. It went 11,47 meters. Do you see? Get a positive answer. That positive answer means down. Because we said down is positive. Doesn't it make sense? If B is dropped, it's going to cover a displacement that's in the positive direction. But you can't say that's the height of the building. We only know that's how far it went in the 1.53 seconds. Now in the same So I'm going to actually draw it in my picture. It went 11,47 meters. Now, how far did A go in that time to its maximum height? So all I'm going to do is I'm going to go back to all the stuff I had here for the orange bit. Do you agree I had the initial velocity was minus 15? Final velocity at the top is 0. G is 9,8. You can use the time. I just always say to my students, what if you calculated it incorrectly? I don't want to, yes, we do positive marking, but I don't want to get dodgy numbers by the time I have to go draw the graph. So actually, this is what I have. That's what I'm looking for. What is the change in position of A for that orange part? And we should get a negative answer, right? Because it's gone up. So if I look at that, do you see I don't have time? Okay, well then don't use an equation with time in it. Ha! Tells me which one to use. So let's go. I'm going to put it here next to this one. So we've got final velocity squared is equal to initial velocity squared plus 2g delta x. Final velocity for A is at the top, 0. Initial velocity, it's minus 15, and it's that whole thing that you square, that it'll become positive again. Plus 2, g is positive for this whole question. There's change in displacement. So look what's going to happen. So if I go 15 squared, that's 225. Do you agree when I take it to the side, it becomes minus 225. On this side, I've got 19,6 delta x. So if I divide on both sides by 19,6, you will get a negative answer of 11, that's interesting, 47 becomes 48 meters. Okay. And yeah, that actually makes sense because it's being thrown up. So that's not a problem. Okay, so we said initial velocity was minus 15, final velocity at the top was 0, g positive 9,8, and that makes sense. Okay, the fact that I got that negative answer, remember minus divided by the plus is a minus. I'm going to change it. Do you agree? It actually means that it went 11,48 meters up. That's what happened. Okay, now, even though one answer is positive and one answer is negative, you don't go and subtract them. Because what's the distance? So one went 11,4, what was it? 11,48 meters up. One went 11,47 meters down. So I'll have to go and add them. 11,47 plus 11,48. And the total distance between them is 22,95 meters. Because I've moved that up a bit. Because I've added them. Okay, so this was now my answer for question 1.2. Sorry, 1.3. That was the biggie. That was the one for 7 marks. So you can understand that I had to go and do multiple calculations in order to get it. But before I go on, I'm also going to indicate this for myself on these pictures. So this thing went 11,48 meters up. Just that I've got that for myself. Okay. Now comes the one that you guys don't like. So it says sketch a velocity time graph. Okay, in the answer book. So they're going to give you space to draw that. For the motion of ball A. So not B, not both of them. Only A. From the time it's projected until the time it hits the ground. And there's going to be certain points we have to put in. Okay. So let's first go, and I'm going to teach you a little trick. I'm going to zoom out. Okay. So when it comes to these graphs, the vertical projectile motion graphs, I always think about, I'm going to draw 2 little people here. Okay. The first thing is, always go and have a look at what down is. Always go and have a look at what down is. If down is, like we said, positive, if down is positive, do you see the little positive guy? Then your displacement time graphs are going to be these little bowl shapes. So if I go and draw them, depending on where the frame of reference is, it's going to be these bowl type shapes. Because remember, when I go and have a look at a displacement time graph, that gradient gives me velocity. So on a VT graph, you never have these bowl shapes. On a velocity time graph, you're going to have, it's going to be straight lines, above or below. But now you need to look at that gradient once again. Okay, because the gradient on a VT graph is going to tell you about acceleration. It's going to tell you about G, which is why this gradient is constant. If you remember, gradient is change in Y over change in X. That's gradient. So do you see these lines? Don't care how see the lines, they're constant. Why? Because G is constant. So if down is positive, doesn't it mean I'm dealing with a positive 9,8 throughout? So it means I'm going to need a positive gradient. Lines that look like that, not like that. Okay, so we're going to be looking at these lines. Now they said they want us to draw a velocity time graph, and it's for ball A. So I'm going to put that in. So I'm going to go, it's velocity in meters per second, time in seconds. Do you remember the initial velocity of ball A, the one that was thrown up, was minus 15. Minus 15. So I'm starting my graph here at minus 15. Right. What happens when it goes up? It slows down and it stops. So that, do you see positive gradient? Because we've got positive 9,8 meters per second squared. And it shows that this thing is slowing down from 15 to 0. Hey guys, but I even know the time. Didn't that happen at 1,53 seconds? Then it's going to carry on falling. So I'm not changing the gradient. Do you remember it's going to get to that same point again, the yellow part? So at that point, it's going to be positive 15. But I also know that that's going to be then double the time, which was the 3,06. So from there to there is another 1,53 seconds. Okay, but now I've only done sorry, I'm going to highlight them in colors. That's the orange part. When it goes up, hits 0. The yellow part was the whole thing. If I go back, be careful, because the question says, sketch a VT graph, a velocity time graph, for the motion of ball A from the time it's projected until it hits the ground. So in other words, this thing must carry on falling. So never change the gradient on a VT graph. It's a positive gradient because G is positive 9,8. Now I just want to go and have a look. Do they want the time that it took to hit the ground? And do they want the final velocity when it hits the deck, when it hits the ground? Not when it's dead in the ditch. The final velocity will only be 0 at that top, that maximum turning point. It's never 0 in your hand or when it's dead in the grass. Okay, so it's only 0 at that maximum height. So this is that instant just before it hits the ground. So let's go back. Initial velocity, we've indicated it. That was the minus 15. Time taken to reach its maximum height, we've included that. That was the 1,53 seconds. The time it takes to reach its starting point, that was the 3,06 seconds. Makes sense for 4 marks. They're looking for the gradient and the shape of the graph and not any more marks because I don't have to go and calculate anything else. And there we go. That's your entire 17 mark question. And you can have a look at the memo. Just remember, you're going to have 2 varieties on the memo. One for taking down as positive and one for taking down as negative because it wasn't specified in the question.